all of the figures. The x-axis is the measure of turnout according to the model, which is not everyone who voted, but everyone who cast a valid vote for a presidential candidate, divided by the number of people listed in the appropriate eligible voter field, which I think is called sum people in the data. The y-axis is the proportion of votes of eligible voters is the denominator for either the Democratic Party in some of the graphs or for the candidate who was the leader or won each constituency in the other graphs. I don't know. Postal was the string that was in the data that I analyzed. I don't read Korean, and it came to me with these English strings in the data, which I am told were created by a script someone wrote to reformat the data from the NEC website. So I really don't know what postal means. I don't know what polling stations are in Korea, which is why throughout the paper I use the phrase aggregation unit, because I don't know exactly what the different reporting units here correspond to. There was a field in the data that I got, which I cite in the paper, which was a database format. There was a variable which was called name, and that field had various names in it, one of which was postal, another of which was pre-vote, either in or out, and then another one was abroad with another word up part of it. Another one was disabled ship. I don't really know what those mean. I imagine abroad means people who are not in Korea who are voting, but I didn't translate it, so I don't know where that came from. I really have no idea what disabled ship refers to. I assumed, and I expressed this in the paper the way I wrote it, these correspond to administratively different types of ballots that come in. For example, the district votes that are referred to in the A graphs you're talking about and in the paper are in a separate database table, which are called district votes, and I don't know what those are. I assume they're administratively different from the so-called postal votes that you probably correctly believe are polling station votes. So I don't really know what Korean terms even these English phrases that were in the database file I came from. You should be able to download it from the link that it's in the paper.
Okay.
I don't know whether that's the original file that I got, because I've been in touch with the person who claims to have created the data. But when I got to that site, it had various versions of the data with different timestamps. So you ought to be able to get that version, or maybe a modified version he tells me he has created. I haven't checked to see whether he's, or whoever created that website, because his name was not on the website that I got the data from. But if you check on the timestamp, it's near the time that I have in the paper, you ought to be able to get the raw SQLite file that was my original source. I can also then send you, if you want, the full set of programs that I wrote to reformat the data and produce the analysis. So I'd be happy to do that. Just send me an email prompt and I'll send it back. That was just to distinguish the two classes of aggregation units. The eForensics program produces a classification of the observations, the aggregation units, as having no fraud, so-called incremental fraud, or extreme fraud, if you get into the details of the algorithm. But I don't really distinguish incremental from extreme. I don't think that's useful anymore. So I'm distinguishing the points that the program classified as fraudulent, the aggregation units, from the ones that are not. And the red ones show the points, the observations that the aggregation, the observations that the eForensics program classified as fraudulent. Well, I'll try. I just developed eForensics, finished it beginning of September, end of August in 2019. It was with support from the National Science Foundation as a research project. And I have not yet drafted the paper we're going to submit for peer review to describe it. So I don't have that much experience explaining it to non-technical people, but I did teach a class, my undergrad class called Election Forensics in the fall, and I explained it to my undergrad students in that class, who are mostly political science students. So they're educated but not technical, so they may match your level of expertise. On that basis, what I'll say is that the basic idea of the model is that there are patterns of votes, patterns that votes that are not fraudulent should have. And in our realization, these are so-called binomial distributions, or really over-dispersed binomial distributions, which is like a coin flip kind of distribution. If you repeatedly flip a coin, that's 50-50, 1,000 times, and count the number of successes, then you'll get a curve. It won't be exactly 50-50. It will be some mostly symmetric kind of bell-shaped kind of curve. You don't have to have a probability of heads, as it were, 50-50. However, you could have a coin with like a 70-30 bias. And the over-dispersion refers to the fact that because individual voters are diverse, and each one has their own chance of voting for or against, say, the winner or the party that you're focusing on, the aggregate statistics are the means of all those diversities, which means that the aggregate data really have more variation than just that coin flip model would suggest. It's like you used a different coin every single time and considered like the mean of the coins. So that's the kind of baseline in the model. It traces back to an idea that comes from some work that Peter Klimek and others did in a paper published back in 2012, just to cite the origin of it, though our mathematical realization is very different in this particular model. And I better stop before I get into the full history of all that research. The frauds come from assuming, and the wonder of the Klimek idea was to not merely say that frauds occur if you don't have that over-dispersed binomial distribution in my implementation of it, but instead says, here's what frauds actually look like. So my grant was called a positive model of election frauds, and the word frauds comes from the Klimek et al. Piece, so that's why that word is in there. And so what they do is specify the functional form that fraud should have. And so they're particular distributions, and the idea is that votes are added to the leading party. So a limitation of the model is you have to pick in advance a party or a candidate who will be the beneficiary of any frauds. And of course, that's just an assumption you make. It may or may not be right. And what can happen is that party, or I'll use the word party here just for simplicity, that party can gain extra votes that they shouldn't have had by two mechanisms, either by having votes that were not votes at all counted for them. I call this manufactured votes, like ballot box stuffing. And one way this often happens in many countries that this happens in is to artificially inflate the voter registration rolls with non-existent voters and then have them vote for you. And this can be done either with paper or by code. The other kind of fraud that the model allows is to have the leading candidate steal votes from other parties. And so those are the two types of votes. And if you add those kinds of additions to this baseline over-dispersed binomial model, what you end up with is data that have multiple local modes, as they say. And so let me draw with my hands just for a second. If you imagine one mode where this is like most of the data are here, say 60% at the top here for the winner, and other polling stations decline, then instead what you'll have is one mode here, and over here there's another mode, which is higher. Maybe, in fact, this is a mode where the winning party is getting 100% of the vote, and there's 100% turnout. And in normal situations, that doesn't happen. And probably the 100% turnout is due to having faked a lot of votes. And because they faked them, they got all of them. And so you end up with excessive turnout and excessive votes for the leading party. So the basic idea is a statistical model has a very precise implementation of all those ideas, and the math is in some slides on my website that's linked to the working paper. But that's the basic idea. So, and it's a you don't have, if there are no frauds, and I've analyzed hundreds of elections across the last few decades in many, many countries with the model, and it's not perfect by any stretch of the imagination, but that's what it does. The key limitation of the model, and there are many, is that even though the word frauds is in the name, and again, inherited from the Klimek et al. Work, frauds, according to eForensics, may or may not be the result of malfeasance or bad acts or anything else. And so in particular, in the Korean case, you have all of these pre-vote ballots that have very high turnout, maybe not all of them exactly 100% given the way I calculate turnout, but extremely high turnout. And it's first order not due to massive fraud, but it's just due to the fact that everyone who cast the vote like that is counted as the eligible voters, and there's no one else. And so you have this artificial reason to have very high turnout in these pre-voted situations. I've analyzed other countries or elections in the US and other places that have a similar kind of thing. I'll just pick a country that comes to mind immediately. Germany has this situation where there are what they call mail ballots in Germany, absentee ballots in California, have a similar kind of situation, and in some cases you can match it to the geography, but you can't in Korea nor in a lot of other countries. So you have this set of polling stations that have 100% turnout or very high turnout, and that's simply due to the administrative fact. And so this is why in the model, as I've done for many other countries in the way I analyze the data, I put in so-called fixed effects or a coefficient for being a pre-vote or not. And that will allow the turnout in the pre-votes to be very high. And in fact, the coefficient that corresponds to the pre-votes for turnout is very high. So that picks up the fact that their mean turnout is near 1. So that's not fraud anymore. That's just the way those votes go. And also you could have different people voting in the pre-voted or absentee votes than in the election day votes. That's a very common observation for the United States, for example. And so I also allow for an extra effect on the vote distribution by party, and that's also an important, significant non-zero coefficient in the model. So those administrative things are very important to take into account. And I've been talking for a long time, so I'll say this one thing and then stop. Because if you look at the raw data of the very first plot I have in my paper, a couple of plots, which show these clusters of votes. There's like a blob in the middle, which turn out to be these so-called postal things or precinct polling station votes. Then there's a lot of votes with nearly 100% turnout. There's another cluster with very low turnout. This kind of picture, without further explanation, is dramatically unusual. It's certainly exceptional among the data that I've seen. However, a lot of that is explained by these administrative distinctions among the different types of votes. And so the kind of 4-part figures that I show through in the second and third figures in the paper and throughout the rest of it are very important to discriminate the fact that we're considering distributions around these different means with different distributions and not considering the whole thing as just one set of votes cast using the same administrative procedures throughout. So to that extent, the eForensics model, and this is one big reason for its advance that we did all the work for to produce it, allows these kinds of covariates to come in to allow for these administrative kinds of differences. We also have different coefficients for the different constituencies because parties have different strength in different places. And so this picks up the easiest usual kinds of distortions that can easily appear to be frauds if they're ignored. Could I say one more thing about it once you guys settle on it?
Yeah, go on.
So the most important thing to keep in mind, which is the source for all of the caveats that I state at the beginning and the end of the paper, is that while the statistical model can detect votes that were added to the leader, or you could say winner, who if you pick the winner to be the one you focus on, it doesn't say why they were added. So even though the word frauds appears because it comes from the history of this model, it may not be frauds in any real world bad actor kind of sense. It could well be normal politics that leads to excessive turnout and surprising balance of votes going that way. It could be the model is also sensitive to actually lost votes, which I don't think is the situation in the United States. In the United States, in Korea, we have a lot of problems in the U.S. with votes being lost through voter suppression and so forth. The model responds to that, which may or may not be frauds. So there's many, many reasons that these so-called frauds might be identified. And so the question is, why are these polling places, if that's what they are, why are they different? And all I have is the voting data, so I surely have no idea why the data have moved around. And so I'm serious when I say more investigations, more evidence is needed to look at the process that the election was run on, and best alternative would be get the paper ballots and manually recount them. That would resolve a lot of the ambiguities if there was a sound chain of custody on those ballots. Yeah, I understand, and many people have questioned about this point, and I did understand that when I did the analysis. And this is why I mentioned this case is very analogous to German elections. The rules are different, but it's very similar in this respect. There you have so-called mail ballots, Briefwahl, they call them in German. And people choose whether to vote by mail or vote in person. And if they vote by mail, then the number of voters is just the number of people who chose to vote by mail. And so there's no other unit. And so if you simply count all the votes cast divided by the number of people who cast them, that's obviously 100%. However, especially in the data I got from Japan, not all of those votes that were pre-votes were valid votes in the data that I got. And so some people apparently messed up their ballots or did not cast a vote for this office. I don't know if there were more offices or something, but not everyone cast a vote for president or vote for this legislative office, by which I mean in specific that I summed together all of the votes that were counted, reported for the parties, and that's the number of valid votes. There was also a figure in the data I got that calls itself valid votes, but that seemed to be not really associated with the number of votes reported as having been cast for a candidate, so I did not use that number. Again, I don't know how that was constructed. And so this is why in these figures D, one sees many of these pre-vote units that do not have a 1 on the y-axis. I was surprised when I saw the low numbers for some of these units, especially the ones along the diagonal in the picture. I thought, well, something's wrong, but I have no idea what's wrong. I've heard various suggestions, people saying maybe it's a typographical error, maybe this, that, the other thing. I can't go just manipulating the data based on what I think, because these are the data that there are as of the time I did the analysis. I've, since I did the paper, received 2 or 3 alternative data sets supposedly produced that are possibly better. I have not had a chance yet to look at them. I'll be looking at them probably over the next couple of days. And so we'll see whether they differ in regard to this point or other features, in which case, if there are, well, any differences, really, I plan to rerun the analysis with the different data sets to see if the conclusions remain the same. I certainly can't say what will happen if the data are different. However, I will point out that in the picture, in the if you're looking at figure 4 or figure 5, there are some points in the pre-vote graph D that have 100% turnout that are blue. And so the model does not classify all 100% turnout pre-vote units as fraudulent, just some of them. And I can't tell how many there are from the way the graph was made, because I plotted the blue dots first and the red dots are on top, and so they kind of hide the blue dots. But there are many more blue dots than red dots. 60%, I believe, in figure 4 are blue, not fraudulent, according to the model. So there are many places with 100% turnout that are not fraudulent, according to the model. I don't quite understand the hypothetical you're imagining if you say if the pre-votes are not 100%. If you're talking about the units along the diagonal in that figure, then those have also a lot of red and blue dots. And those are the ones that I think are the most suspicious, because while it should be the case that turnout is near 100%, and maybe a few people decided not to vote, even though they went to the trouble of voting, they sent their ballot in. I'm not sure if they mail it or whatever the procedure is here. These points have, only 40% or 50% having voted for a candidate, which strikes me as strange. You can speculate about why that's there. The most favorable argument is that it's some kind of a data entry error. But of course, there are more difficult kinds of interpretations one might have there about votes being deliberately spoiled or something. So I have no idea why those are there. So to my mind, the real question is those very low turnout pre-vote units are possibly contributing to the other units appearing to have lots of fraud, because the average turnout according to the model has to be lower in a sense to accommodate the, call it, on the diagonal values, and that makes the higher turnout observations look more and more unusual. So to my mind, the real question is whether the modified versions of the data that I have, or if it comes to it, I will maybe fight through to try to build the data from the Election Commission site myself, though I'm sure hoping I don't have to do that. Or maybe the data are just wrong on the Election Commission site. I have no idea. But it's those diagonal points that, to my mind, are probably a reason for a lot of the fraud estimates. And I could test that by deleting those points, but now we're into just see what happens kind of mode, as opposed to really doing analysis that's for the public at the moment. And I will play with these in the fullness of time for my research. But right now, I don't see the reason to delete these points or change those points just on some whims, because it takes a long time to run the model, and without motivation, it's hard to know what happened, why one is making these changes. I've certainly heard people say that they're using my work to support their political argument. I have basically no comment on that. I have no real idea what they're doing there. I've heard they even made a YouTube video or something, so it seems pretty elaborate, but I have no comment. I haven't seen it. I don't know what they're doing. My motivation and the message of the paper are kind of two different issues. My motivation is it's kind of what I do for a living. My main research project is election forensics, which is a phrase I invented back in 2008. I was prompted to start this project by the disastrous election we had in the United States back in 2000, which produced George Bush as president, and I wrote a paper called "The Wrong Man as President." So I thought that was really a bad thing. I won't go into the details of what I argue in that paper and an earlier paper about the butterfly ballot. But at that time, I realized there's no scholarship, there's no research, there's no literature on how to diagnose elections. And so I took it upon myself, and a bunch of others, a few others around the country here and around the world, have taken on similar missions to try to bring some scientific basis for evaluating these kinds of situations where one party really feels robbed and says the election was stolen, and of course the other party who won say no, it wasn't. And is there a way to decide this? The best way to do this, to resolve lots of these questions, is to use paper ballots and then count the paper. And so-called risk-limiting audit technology is being developed by some others, especially to do that. So I would highly recommend manually counting the ballots, and risk-limiting audits mean you don't have to do a full manual recount. You could just count a sample maybe and decide that it's probably likely the outcome is correct. So part of my mission to write the paper, the reason I wrote it, is just to use it as an example. I tend to do this. People reach out to me and say, help me, usually people who lost, saying, you know, I was robbed, and help me. And I say, do you have data? So in this case, an academic from Taiwan, I think he said he was, I'm not sure, who I acknowledge in the paper as having pointed me to the problem, Hun Chung. He said he knew a former student of mine, and so it's an academic. So he was the first of several people who reached out to me about the election, but he was the first one who pointed to data. So he didn't create the data, but he pointed me to the link. I got the data. I had a few minutes between the end of semester and grading papers. So I cleaned the data or rearranged it and ran the analysis. The first plot in the paper that shows all these clouds of points was astonishing to look at. I'd rarely seen such weird patterns in data. So I thought, oh my God, what's going on here? I was a little relieved to see the A, B, C, D plot figures, which show more normal distributions by these 4 types of administrative features. And I broke it down a little more detailed than that, but those 4 are sufficient to display the figure there. And then ran the analysis and wrote it up. And so I've done this for other elections using eForensics. I wrote another working paper about the Bolivian election. That's also on my website. And before eForensics, I've done this for many other elections that have sort of gotten monkey cage pieces published out of the Washington Post, or just things I post on my website. You can look on my website to see a bunch of them. It's sort of what I do. It's my research project. It's my teaching project. And so figuring out what's going on in this case, because there are strong arguments why it's just natural politics that are causing these anomalies. And there are strong arguments of why there's a bunch of bad acts. I don't know which is true. Usually a little bit of everything is true, and it's even more complicated than you realize. So it may be that I'll develop this case as I go further by getting more information about the election that goes beyond just the limited data that I've looked at. So my message of the paper, finally, just to have a brief answer, is this is just the state of the art of one particular approach to studying these questions. And one can see how many issues remain to be researched. And you can also see the limits of this kind of statistical analysis. It just leaves a lot of questions. And there are things you can do. Look at the paper, count the ballots. That could resolve a lot of the questions. But even there, of course, that's not going to resolve everything. Sure, that's possible. I've heard that. And that's specifically, I've described it as a get out the vote kind of effort. But it's a kind of strategic behavior, which is many people are voting because they believe a lot of other people are going to vote early. And they, in this case, apparently turn out to be supporters of the one party. And the other party has a message of do not vote. So they're more likely not to do that. And so this produces a kind of similarity among different individuals' actions, which is the main complication that eForensics is not designed to handle. I don't know whether that's enough to produce this pattern. The future direction of my research on this project is immediately to do various things involving some fairly complicated modeling, simulations to see how big such effects can be. So I don't know whether that is the or even a reason for the frauds, but to my mind now, that's certainly a kind of natural political thing that has potential to produce the I guess you'd call it false signals of malignant behavior. But I don't know for sure whether that's the case, and so it's just a possibility. Well, from what I've heard, part of the election involves electronic tabulation of the votes, and this is the main reason for the rise of so-called risk-limiting audits. So in the United States, I'm not a computer scientist, but I know a lot of computer scientists and work with many of them. And almost every computer scientist I know does not believe that electronic technology is immune from rigging, hacking, corruption of various kinds. It's impossible to verify what happened electronically, is sort of what I take from many, many people, some very sophisticated and well-known, who argue this. And so their argument is that there's no way to trust officials or anybody else that, you know, I'm honest, because who knows? And you shouldn't have to rely on trust. And so if you have a system where the voting occurs on paper, so the voters have a chance themselves to know what they did, and they may or may not look at their ballot, but some fraction will, and they all could, then you preserve those paper ballots so that everyone knows that the ballots you have are the ones that were actually cast. And then you count them by hand using procedures of having teams count and multiple counts maybe, but the counting technology is also pretty well done, and the risk-limiting audit could be done in a public way so that people can watch it on video if they can't be there physically to see it happen. This is a set of methods that have been developed, especially with support by computer scientists throughout the United States and in Europe, I know for sure, and maybe a couple other continents, to really address the impossibility, they say, of trusting electronics. And so that's the first thing I would say. If the argument is our electronics are perfect and can't be hacked, I believe that's not a thing. I think you just can't trust the electronics. My view is that as I said, the computer scientists studying election security and integrity that I know, they've had big competitions where essentially all kinds of voting technology used in the United States and across Europe have been brought to meetings or hackathons, and all of them have been attacked successfully in these kinds of environments. So even the machine that's never online, it's been demonstrated that, you know, while it's in storage, it may have software corrupted by a so-called virus that erases itself after it does things. So they're the computer scientists who do this very clever at attacking electronic systems, penetrating apparent security. So that doesn't give me extra confidence. The point of the risk-limiting audit is that it's very convenient to use electronics to do vote tallying, and it makes reporting quicker. And if it works, it has some virtues, many virtues. But the point of the risk-limiting audit is to provide confidence that the electronic tally is correct. And so it may be that you can count a pretty small proportion of the votes using the random sampling kind of schemes that are designed as part of that, and get great confidence that the rest of the ballots that were counted electronically are correct, and then stop. So it doesn't change the system, and those who believe in the technology may find it validating that the manual or partial manual count that the risk-limiting audit can support proves that their system was not the problem. I think that would be terrific for the legitimacy of the election, to have that demonstration be not only in Korea, but routinely part of elections everywhere. Well, either one could happen. I've studied many elections, including the election in the United States, the 2000 presidential election, where Florida was the main state. And the best summary of that analysis is, while the governing party in Florida did a bunch of things that were probably politically motivated, to like prevent people from voting. And that everything was sufficient to change that election outcome because it was so close. But there were tens of thousands of votes that were misdirected, were lost because of mechanical failures, administrative failures, bad ballots, confusing ballots, just no frauds in the conventional sense, but just incompetence, I'll put it that way. And sometimes people are arrogant about their incompetence. So that's certainly a thing that can cause the voters to have their will thwarted. You can get the wrong outcome for that reason. I wouldn't call those frauds necessarily unless someone designed the system to have all these problems, which can happen. But you could also have people trying to affect the outcome by deliberately inducing certain changes. I have no idea whether that's the situation in the Korean case. I've seen allegations, second and third hand, people sending me emails saying, this person did that, this party did that. I have no idea. But it's important to think of two different kinds of attacks that can happen. And one is an actual attack intended to change the outcome and get a candidate or party to win when they shouldn't have, so to speak, and then to get away with it so no one notices. The second is to deny the credibility of the election. So to have an attack and everyone can see there was an attack. And so Russian elections I would characterize as this kind of thing, where there are major fraudulent actions in the natural language sense of fraudulent in Russia. Everybody knows it. You can see huge patterns in the data that show the patterns of vote manipulation because apparently they don't care that they're known to be so powerful that they can just cheat right in front of everybody to borrow a title from a paper. So in Korean case, denial of credibility might be as big a threat as actual changing the votes. It may want to have the appearance of things being wrong, even if nothing is wrong. Of course, something could be wrong as well, and it could be, well, we talked about natural politics, could be some bad actor somewhere wanting to steal the votes or something else. I don't know which of those, if any of them, has happened here, but the ways that elections and the legitimacy of democracies can be undermined is many. And so that's the main reason for my work on this project, is because I think legitimacy of democracies can be fragile. And if elections are undermined, then there's not much between that and very bad situations. It's fair, but it's not necessary. As I said, there are all the ambiguities of whether the so-called frauds from the e-forensics model are actually the result of bad acts at all. It may well be that these are symptoms of some other kind of thing that are generating false positives by the model. Even if there are bad acts, I'll use that phrase, the complexity of the ways that votes can be manipulated is many. And so the model focuses on those two. The biggest limitation that the model has, that is, again, a focus from my future work that's ongoing, is that the model cannot handle lost votes. And so if it's fraud, you might imagine that a candidate got a bunch of votes and they simply were not counted. They just threw the ballots in the river, is my colloquial thing. And so you have a bunch of lower turnout, lower votes, and what does the model do with that? I found applying the model to elections where I know a lot of votes were lost like that, and again, I'll mention the Florida data that I have from 2000 in the United States. The model does show in not just 3 dozens of cases that the candidate who won tended to benefit from frauds. But what actually happened was just that the other candidate lost votes. And so the number of such votes in 3 cases I know very well in the United States happened to actually line up, where the number of so-called e-forensics frauds is approximately the correct number of votes that were lost by the other candidate. And like in the Florida case, mostly those lost votes weren't fraud, but just incompetence. So I have not heard anyone allege in the Korean case that a whole bunch of votes were lost, but that doesn't mean it didn't happen. It could just be they aren't focusing on it. So that's one kind of mechanism that occurs very frequently in elections around the world that the model does not handle in a straightforward way. And future work has to figure out how to do this. And I'll let you know in a few years how that works out. And there are probably many, many other kinds of things one can think about as ways to manipulate the election, if that's what it is. But I think manufacturing and stealing capture most of what often happens in a lot of elections, and losing or throwing away votes is the third one that often happens. And it's a big deficit of the model that it can't credibly handle the throwing away, but it may be a bonus that it picks them up anyway, but that gets into a deep question of interpretability. But it's important, again, not to confuse the formal fraud notion and manufacturing and stealing notions that are implemented in the model with the greater complexity that can happen in the real world. Well, I have two different models, one of which allows the Democratic Party in every constituency and every aggregation unit to benefit from frauds. It's kind of like the A model. And then the second model uses the winner or leader in each constituency. And of course, United Freedom, or whatever their name is, party won some constituencies, and apparently independent candidates and other parties won a couple. So it's an artifact of having picked in advance before running any analysis those to be the parties that can benefit from frauds. I did not calculate the potential seat change in the model that has the Democratic Party everywhere committing fraud. So I really don't know what happens in that situation. The thing I want to say goes back to the issue of not interpreting the model too seriously, by which I mean just because the model says there are this many fraudulent votes, 1.4 million or 1.1 million, and the two models, I think it's about that, that doesn't mean that's how many votes were actually affected by bad acts. The number could be 0, as I said, or the number could be much higher. This model is saying something is really off, according to my notion of what a fraud-free election should be and what my model of fraud should be. And to get a sense of how bad it is, the last thing I would want people to do is to believe the numbers out of the model for the number of votes lost or where they were lost. I had a student who studied these Russian elections, and he found that these kind of predictive numbers were pretty close to true according to a large variety of sources in Russia. But again, how do we know? Because people don't confess, I stole the votes and here's how many I stole. So it's just there was consensus from a bunch of diagnostics. So I wouldn't take the numbers that seriously. If there's evidence, and apparently there are arguments, that there are many bad things procedurally that were done, or there was real malfeasance, then the burden is on the process and the parties and the government to create legitimacy for the outcome. And I know one way to do that, which is to keep the ballots in good chain of custody and count them manually. And that will rule out a lot of allegations. Of course, people will then say, oh, the ballots were manipulated and so forth. And that could be another set of issues. But I wouldn't take the numbers, especially from the model that has the constituency leader as the beneficiary, where you had 9 elections that the Democratic Party won and 6 that the other party won. And I wouldn't take that as a gold standard number. But on the other hand, it may be right. I don't know. Again, I don't really know. Yeah, the one wrinkle is I didn't really get the data from Chun Hum or Hun Chun. I don't know which comes first. He pointed me to another source from which I got the data. Not really. I understood it was very analogous to absentee mail-in ballots. The particulars of how it was done or physically how the thing was processed, or more specifically, how the units I have in the data correspond to physical geography in Korea. I don't know that, but I was very aware that the number of eligible voters, or the sum voters it was called, was just the number of people who showed up to vote that way. And so I was surprised when I discovered such low valid vote proportions in those ballots.